Okay, we'll assemble SCUTTLE version 2.4 today. And basically it's going to consist of making these two wheel brackets with their respective members and then separate assemblies for these two guys. So I'm going to pull out the box of brackets, hardware, and then we're going to have two of those. These corner brackets made of aluminum use the drop-in style nuts. So, and they use the M6 screws. And just pour them all out. And they don't need any washers. So you can individually take the brackets and get a nut ready. This is called a drop-in nut because it can drop in like that. And each one will be populated with two drop-in nuts. And the other M6 screws and their respective extrusion nuts will go into the wheel brackets. The wheel brackets use the slide-in nuts rather than the drop-in nuts. Okay, then we're going to just orient these so that they're going to mate and make a rectangle with the other extrusions. You want to have those hanging down low enough that they drop in past. Don't fasten them all the way because then you can't clear this lip. Then I just tighten them enough so that they stay steady. And you don't have to worry about the precise spacing of the 90-degree bracket yet. Really putting no torque. I just bring it down to where it touches, and you should keep the weight of the screw down to make sure gravity lets the nut hang below the channel in the extrusion, and it gives it clearance to turn. You could look closely at that when you have your kit, but basically it's the rotation of this that needs to happen. So those are front and back extrusions. Then we'll have this R means right hand, a right hand wheel bracket. They also use the same screws for all except for two. So, and then the nut, this is what the slide-in nut looks like. So I get the slide-in nut on there. I'll do this one by pre-prepping, and I'll do the other one by sliding them in ahead of time. Depends on your preference. And the smaller face of this nut needs to needs to contact the plastic, or the broad face is exposed towards the center line. So this one, at this time, when you assemble it, it doesn't matter the orientation of your extrusion since everything's symmetric. You just have to know that you're sliding these in on opposite sides of one another. So that will go in. Doesn't matter here or here right now, but it will just matter once you get a little further along. I think it's best to get the wheel equipment populated on here first. So I'm just gonna pause at this stage and switch to my wheel, and I'll remember the most optimal way once I get a little further. If your screwdriver is magnetic, then you can pull that, and so you'll need to see the hole in the nut. So if you tap the extrusion, you'll walk the nut down to where it needs to be. So now I can see the threads. Drop that in, and I'm gonna assemble this all with the short, the same length screws, and replace 2 when it's all said and done. The 2 that are longer will mate to this power adapter, this 5-volt adapter. Okay, so once again, they're just snug enough to not go anywhere, but they're not tightened yet. Now let's get into the wheel assembly. So wheel assembly consists of the M8 screw and the wheels. One washer stays on. This bolt, I recommend having a dish or something so your screws your hardware doesn't roll around as you get things put together, especially if you have a smaller table and you're bumping more. So one washer stays on, then that passes through the wheel from the outside. And also I'm going to test that my holes have a nice fitment on this. You should be able to push it in, and there shouldn't be clearance, but there also shouldn't be, well, it shouldn't be this hard like that. So we're going to do a little work on this bracket before we do the assembly of this bracket. Otherwise the clearances, we want to video and demonstrate the way it'll look when the clearances are proper. So I'll come right back to that. I'm going to assemble these 2. Washer goes against the bearing, and you should be able to pull down and spin with no friction. Then we get a plastic piece that slides onto there next. The plastic piece is the wheel spacer. It has the WHL for wheel and the small arrow that points down, that points towards the wheel. And the chamfer is on this end, while this end is flat. So the chamfer mates with the inner race of that bearing, and they're allowed to spin together when they're all touching. So from there, we'll just get the parts laid out. One of these for each wheel. And we're gonna, we'll need to put hardware in these. We need motors. So let's do these wheels first. Those are easy. And they're gonna use the same screws once again, but this time with hardware, with washers. So the washers of interest are M6 lock washer plus flat washer on each one. So these casters only have three screws on each caster plate. We go lock washer, then flat washer, then it's going to pass through, and then we're going to put the drop-in nut. And that's a set. Lock washer, flat washer, pass through, drop in nut. This will end up having a sensitive clearance where you need to clear the top of the screw for the caster to spin all the way around. And we're going to put 3 lock, 1 flat, and insert. And we put a nut and at this point, you actually need to pay attention for a moment to where you're adding the screws because they're symmetric, they're not identical. I'll show you what I mean by holding it over the extrusion. So if this is the front and we're upside down now, then you can have screw, 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 and on this one, screw, screw, screw. So at this very moment, I could make the mistake of putting my screw in here, and it would match, it would be identical instead of symmetric. We want them symmetric, so that's the hole I do. You go screw, washer, flat washer, pass through, set the nut. Okay. Then we might have to backtrack slightly later, but if we get things fastened on, it keeps our kind of, your brain's able to see how stuff gets laid out. So I don't mind backtracking one step. We don't have to tighten things down deeply, just enough to hold steady again. We really treat tightening as one step at the end of everything. This is, if you could get this shot here, that'll show you how you may need to just push down just slightly so that nut can rotate like that. If I don't push down, or if I have things offset, then it will hang up instead of rotating, and you won't get the fastening force. So from there, it's just clamping more, but now the nut is seated the right way. So that's good to go. Now, conditioning this will be an item. Let's get these motors ready. And you also need to pay attention to which motor. They're asymmetric, where both these wires will go to the motor driver. And if I'm sitting on SCUTTLE right now, then I'm pointing forward, where the right hand motor has a longer cable. So both these will reach the motor driver. That's going to be on the left hand, the driver's side. So this is R. I'm going to actually, if you don't mind marking your motors, you can call this R and L, and then so R is going to go here. Sorry, let's double check. This says L, so we're going to put it on this guy here. Then don't get confused and try to plan which hole. Out of these 6 threaded holes, we're only using 3, but you don't need to know ahead of time. You're just going to set it in there, and then you don't want your motor out like that. You're going to have it twisted, almost touching, because the shaft is offset. And as you rotate it, you're going to find the holes line up with your wheel bracket. Hold it with one hand and clamp. And then we need our M3 screws. The entire robot just has 6 units of M3 size screw. So you don't need to worry about how long it is or check the length, because key point is, of all the fine screws here in this pile, The M3s are larger in diameter, and you can notice those. They're also countersunk. So I find looks like 3, 6. I may have one extra, so we'll get initially assembled and notice if we have an extra on accident or if that goes somewhere else. This is my magnet bin. I strongly recommend a magnet bin. Has little magnets on the bottom so your stuff doesn't bounce away. Okay, and then before I actually thread them, I'll just double check. Right, these thread into the motor gearbox nicely, so that's going to work. Double check. I had R and 1.5R. You might have a new wheel bracket when you're watching this video, so it might not be 1.5, but it will retain the right and left designation, as this design is symmetric and not identical design, but symmetric design. And this, so now this screwdriver is too small. I could feel it right away. We want to be using a number 1 Phillips 1 for this. Usually this heavy kind of screwdriver is usually number 2, but I happen to have a different tip. You can feel there may be slight deviations in the hole where, okay, it doesn't drop in. This is a clearance hole by design, but it might have a little friction. You should just be able to tap it and it'll drop this thickness, 6.35 millimeters. So get that tightened. This one, if you're sure your quality of your wheel bracket's good, then you can tighten these all the way, and that will consist of finger force. In our instructions, we'll try to divide assembly of screw torque into either finger force or wrist force, and this is definitely a finger force. Everything you see here is finger force level of torque, not wrist force. So we'll go ahead and put the other in. Just check them to line up. You really just, if you're doing a placeholder and you're switching assemblies to work on a different area, you just need one and it'll be fastened. I'll put 3 in, even though we still have to check that wheel bracket. Oh, this is the part where I use my electric guy. Okay. These ones, strongly recommend. I think they're down around $25 now. They recharge with a USB cable, and honestly, the torque provided by this motor is just about what you need, and maybe just do a gentle turn after it stalls out. And don't turn it while you have the motor active. You could damage the motor. Okay, so we have, now we get the positioning checked. This is the left hand wheel, which is driver's side, if you had a driver in your scuttle. And that means wheel will be outside here. And that means we don't want it up in the front, we want it near the back with a little extra space for a 90-degree bracket, that one. So as I assemble, I try to start positioning things to visually see what's the next step. This guy, I'll go ahead and try and finagle this. So this is, one way was sliding the nuts in after you've put the bracket on the extrusion. This way is put the nuts on the extrusion, on the wheel bracket, and then slide your extrusion in. So, and the tricky part is feeding those brackets in. I'm going to point it towards this camera so make sure it's actually showing for sure on that direction. And this one can be a hassle. I tend to do it the other way these days. And then the challenge is get that lined up so the slide in nut slides in. You might have to tighten the screw just a little to get the depth agreeing with the slot. And then that slides. Then the next one slides. Well, it looks like I lost a screw, so I'll just proceed and slide it in after. This is the assembly sequence this is part of the sequence that matters for you, for your convenience, because you don't want to already have these brackets on or all four channels, aluminum channels together when you need to adjust this or slide in one more nut. Did I drop the slide in nut on the floor? This is the drop in. I'll come back and grab that. It's pretty obvious when one of them is missing. So, all right. Now these motors won't point the same way. They'll point shaft out towards the wheel. So this one shaft is out towards the wheel. That means I need to slide the whole assembly back. Now, again, right hand has a long cable, left hand has a short. We can put together the rods assembly. I'm going to save this hardware. It's pretty obvious the M8 is larger than everything else, so it's okay. If you mix it up, it won't be hard to sort. Now, aluminum rods assembly. We hope to evolve this design from version 2.4. That's this assembly. SCUTTLE version 2.4 uses these aluminum tubes. They're 1/2 inch diameter. And it's good to treat these as one assembly with your brackets. Next version, we hope to have everything transitioned over to DIN rail. So this is the motor driver bracket. You'll notice it has places for 2 motor drivers, but the robot only has 1. That's just spare. And 2 of the 4 holes have their brass inserts. That's a threaded insert. Then if I'm on the driver's side, if I'm in the facing forward along with the robot, then this goes all the way down. Just enough to make the space for Raspberry Pi bracket. Pi bracket or other CPU bracket is going to have the position for the circuit here, I2C board there. We're maybe more than midway through our assembly, so now is a good time to take inventory again if you haven't. Make sure that you don't forget something. If you're not paying attention to the manual and you're free, going freestyle, then just looking at all your parts, taking a pause is a good way to notice if you forgot something. I'll put the 3 brackets here. So front of the robot, back of the robot, the battery bracket with no cells in it right now. It's going to have the terminals pointing to the back of the robot. Okay. Then the only thing you need to do is basically make these approximately level with each other. You don't want to make a parallelogram by having them offset. Then the 4 rod brackets. Rod brackets have a feature that slides into the extrusions. What I recommend for people is go ahead and put them on the rods, even though you'll need to take them off in a bit to verify the orientation, because this, well, if we compare right to left, the gap points forward on this side, the gap points backward on this side, because these actually are identical rather than symmetric. That's to save the number of designs we issue and people have to keep track of. Then this is just for visual checking. We're sticking it on the rod to say which way, and you can slide them in this way maybe, or you could snap it. When you snap it, you should have a nicer sound than that, but sometimes it goes. You can feel it with your as you're pressing it. Should be able to be a strong finger force and just go in. Now, I do this on the rods to not get misoriented when I put the rod brackets on the extrusions. So that means the question I have is which way is it oriented and on which extrusion does it go and on which face. Bottom of the robot, right hand side rod bracket slides in, and this is going to take a little finagling again to get it started, and you might have a little dust of plastic from entering the aluminum, but that's okay. After this, the job of these feet is to always push outward and create friction so your rods don't slide around while you're driving. Front and back, it doesn't matter because they're identical, but you just have to get the orientation right. These prints, you shouldn't hear the little bits of cracking that I'm hearing, so that's not the best example. We have to double check the quality on these specific pieces. So that goes in, that goes in. What I see a lot, pretty frequently, is it can be tough for you to fit them in, and you don't want to put them backwards or on the wrong face. Depending on the sequence, this is where the sequence helps you a lot. Okay, what parts do we have left? We have these encoder brackets that we'll fasten the encoders to those. I think even before soldering the encoder, I'll go ahead and assemble the two. These come with a magnet each. Those are very special magnets that get sensed by the encoders. And I'm going to just put the boards on the robot now, and then I'll take them back off and solder them after we get 100% assembly, and then it's okay. Since it's so modular, most things you can remove without multiple steps. Keep things bagged if you can. These ones always bounce around and get stuck to some piece of metal, and then they can be hard to find. So these are identical, but the assembly is symmetric. They're both could be right or left, but you need to choose when you assemble this on there. So I'm going to position it over the shaft, because the shaft is where the motor pulley will get fastened. So here's how it goes. My two screws of size M2.4 countersunk. We look at this assembly. This version right now, 2.8, has the countersink feature with the countersink, a chamfered shape around the head. Countersink, not counterboard, but countersink. And then it's gonna go like that. Before I tighten any of those down, I'll get the encoder put on. And key point for assembly direction is hold it there, and you know your connector is going to be in the front of the wheel assembly. So that means these header pin row will be in the front. Next, we find the screw that goes on there. I haven't poured it out yet, so maybe it's... I might have to grab those. Okay. In this case, we've made some changes on how we ship the small bags. We try to make it convenient, but sometimes there will be changes. I can go ahead and dump this, and I'll keep these separate. Okay, I2C circuit board, and some small screws, and the header pins. So the header pins are to be soldered. I'll set those aside. And then the small guys, these use Phillips 1 or 0 size screwdriver, and they're coarse threads with a pointy tip. That ultimately means you're going to get self-tapping performance. And with the self-tapping screw and a piece of 3D printed plastic, you don't want to assemble it a bunch of times. Removal and replacing many times will wear out that hole, but on the first time it should have a little friction, hold snug, and about requiring as much torque as this thing has. I'm letting off a little early. I can feel it twist when it clamps the board for sure, and I can't wiggle the PCB with respect to the bracket. Then it's good. There's never any large forces on this assembly, so tightness is not necessary, but gap free is necessary. Grab the other one. Assemble these in pairs. Whatever you did for the right hand, you'll do the opposite for the left. And again, I can do something like put a little R here for myself. You won't need it visible all the time. You just need it visible for if you move things around in the assembly. That one's going to point that way. So symmetry. And I'll put a little L here. As long as you're drawing on something green on the PCB, you won't hurt anything on the circuit. When you use these ones, it's helpful to have a magnetic driver. Check your holes. There's only 2 holes in the design. And I don't tighten that one all the way. I leave it loose so the board can find its position when I add the second one. There's just a little clearance around the diameter of the screw. And we use that clearance to let the parts find their resting spot. Okay, so we'll go here, and I don't assemble it yet because wheel assembly has to be finished first. Well, the wheel pulley. So motor pulley. It has a D shape on the shaft. That's going to line up with the D feature on your pulley. And this should be able to be pressed on with, wrist force, and no more, no less. This should be strong, and yeah, if you have, 2 double finger force, maybe that's good. And it's going to stop when the shaft reaches this very small lip, small feature that creates a barrier. Then you're bottomed out on your shaft. You can see the shelf. We call it a shelf. The very small feature between the top portion and the shaft portion. And after we push that on, it's magnet time. So this is where we release the magnets. Your magnet will want to run around and find anything steel to clamp onto, like that. So we don't release the magnets till we're ready. We use a hex key is a really good tool to use, or the base of one of these. This is a 1/4 inch hex driver, and it fits nicely to keep this secure, and you have something to hold on to. We push that in. We drive the magnet into its position. It's going to be flush, or maybe slightly protruding, very small amount, but flush is, if it's flush or close, then you should be okay. This one we assemble onto the motor. I'm using my fingers just to lightly rotate that until I find the D position, maybe double check visually. but you can kind of feel it seat before you push. This is the right amount of force. But the tolerance on these ones sometimes is hard to achieve, and if you have any defect, you want to catch that and get a replacement pulley, motor pulley. If it's like, if you need you use your pectorals to push this together, then you need to swap that out. Right. Magnet time. I don't like to rip these bags. They're pretty strong and stretchy, and it's just one more chance for the magnet to jump out. I always keep a knife with me. Then here we go, pressing in. You can feel it stop solid. Also, if the tolerance on these 3 grips is off, lucky thing is this magnet will stay linked to the end of the shaft just by attraction. Next, we still won't fasten that yet. Next is going to be this guy. So, conditioning, I might pause this video for boring those holes to precision before we continue filming. But let's do a quick tidy up. We'll talk over anything that's remaining. Hammer bracket. This is the wrench for the M8 nut. This is the stand. Tools in a row. Those, I believe, are just spares, but we'll double check. These are the remaining M3s. No, these are M2.4. These were the ones with the encoder bracket. Okay, something that appears to be spare, I'll just keep an eye out for. These small plastic things will go on a Raspberry Pi or other header pins just to cover them. I'm going to set that aside. Checking my other cardboard boxes to make sure there's nothing. This is a charger. We have a couple variants of charger, so that's not part of the assembly. The gamepad and controller is not part of the assembly. So this is where I get all my cardboard. If it's empty, I stash it back there. This one's empty, so I can stash that. I close it all the way, and that's my reminder that it's been emptied out. This one, wiring. And motor driver. Yeah, that's going to go on the hardware assembly. We empty out the electronics box. SD card. Let's see what we got. Okay, this one can go on. This uses the same M2 course screws that I just had. Okay, there was spares. I almost bumped them. You can also use the electronic screwdriver. Get that on there. And I bring my circuit board, and then I find the holes, make sure they look like they'll be clear enough to accept the screw. It should grab on by itself because it's the self-tapping kind. I'm going to take a seat, get a little more steadiness. Sometimes even if it's magnetic, I'll use just a fingertip to keep it clamped on my device. Oh, this is where also you need to check out for clearance. If we've applied the hot glue, that's a favor to help reduce chances of short circuit, but sometimes this hot glue might be a little bit thick. Then it's going to want to sit a little higher, so I'll correct that. I'll visually check. There's some words printed on the white letters. It looks like I can just trim off of this. I don't want to give instructions with sharp objects, so I'm going to do this outside the frame. You could still film with that camera as a a takeout, but I don't want to tell people that they should use a knife like me. Basically, I'm just trimming off some of this hot glue that created a little interference, and I happen to know the area it fits, but you might have to do a little guessing and checking just to verify. If you put on your own hot glue and it's already hot when you assemble, it'll make sure that it's not too bulky. So I used this knife, but you have to be very careful and anchor everything on the table, like your wrists. Okay, the two holes in the top are indicating whether it's upside down or not. So that doesn't require instructions, but for version 2.3 it kind of did. And it looks like the top is still going to be a little, needs just a hair more trimmed off. And now I'm bumping into I think we're going to adjust this so that we don't send this with any hot glue. It can be helpful, but it's also, there's a good chance of it interfering without any. The same person that adds the cover, the glue, ought to be the same person assembling, I think. So, alright, next, anchored with the thumb. I think I can feed that in. I'm not tightening fully because I need a little bit of wiggle room. Okay, IGC brackets on. Now, motor driver. This is the 12 volt motor driver. Usually we often ship these and clip them first. I think that's worth